All right, so 5.2, question number 6. We're supposed to get through this by today. I don't know if we're gonna. I doubt it. All right, let's take a look. So, how do you add fractions? You got to get common denominator, right? So, how do you get common denominator for 20 and 50? Put them in the box. Remember the box thing? That's how we find common denominators for a couple of numbers. We just stick them in the box thing. And then you go off to the left and you put something over here. You say, okay, what can I put over there that goes into 50 and 20? What goes into both of them? A lot of things. 2, 5, 10 be probably kind of nice. You know, any of those are fine. You know, you do 5 or 2 or 10 or whatever. 10 goes into 50, 5 times 10 goes into 20, 2 times. Can I go again, or am I done there? I'm done because nothing else goes into 5 and 2, huh? Nothing goes into 5 and 2. So what you do is you multiply these numbers together on the outside. 10 times 5 is 50 times 2 is 100. You might have already known 100 is the common denominator for 50 and 20. 50 and 20 both go into 100. So 100 is going to become the new denominator for both of them. Now, I'm going to go back and say, okay, what do you multiply top and bottom to get that common denominator? Like, what do you multiply top and bottom of the 7 over 50?
By 2.
By 2, huh? Because you got to make 100 on the bottom. 2 times 50 makes 100 on the bottom. Here, let me rewrite this. Oh, there's not enough room here. So the original question was 7 over 50 plus 7 over 20, and I know my new denominator is going to be 100 common. So yeah, I go back and I say, okay, so that means multiply top and bottom of this one by 2. There's a few different ways you can figure out 2. You can just take 100 and divide it by the old denominator. Take the new denominator divided by the old denominator. 100 divided by 50 will tell you 2 is what you need to multiply, top and bottom, to make it have that common. Or you can, remember I told you the trick. Did I tell you the trick? For the 50, if you go diagonal, it'll tell you right there what you need to multiply by, 2. So then 2 times 7, 14. And now for the other one, for the 20, you can go divide by 20 and you'll get 5. So that tells you top and bottom by 5. Or you could have just done the diagonal trick, 5. Top and bottom by 5, that one's 35 over 100. So I made both fractions now have common denominator. And so what is that? 49 over 100. Good? Remember all that? Because we're going to do it all with letters here in just a minute. So they're trying to say, kind of remind you how you do it with numbers. And then we'll start doing that with letters. All right, if you got that. Okay, so 3. So start by finding the common denominator. Remember, put the 9 and the 30 and the 81. Put them all in a box. 9, 30, and 81. I'll give you just a second for that part. See if you can find the common denominator. Okay, so what, you could just do 2 at a time or whatever. But if you do, yeah. You know, there's one little trick I need to tell you. For 3 of them, it'll mess you. If you do 9 right away, it'll mess you up. Because 9 goes into 9 and 81, of course, that's good. But 9 doesn't go into 30, but part of 9 goes into 30. Anyway, I don't want to spend too much. What's in a 9 is 3. 9 3 times 3. And you see, part of 9 goes into 30. 3 goes into 30. But not all of 9. So anyway, long story short, just start with 3. 3 goes into all of them, right? 3 goes into all of them. So 3 goes into 9 3 times, goes into 30 10 times. 81 divided by 27. Like that. And then you could do 3 again. 3 goes into 3 once, goes into 9, it goes into 27 9 times. Bring down the 10 because 3 doesn't go into 10, huh? And then that'll be right. Yeah, that'll be right. Yeah, you can't do the 9. Yeah, I don't want to spend too much time on this. Yeah, let's just leave it at that. I'm not going to give you a lot of these or anything. Just do the 3, you'll be fine. All right, and then multiply these guys together, right? Multiply all these together. So is it 810? 810? Yeah, 810. So 810 is the common denominator. You good so far? So that means I'm going to make all 3 of them have a common denominator of 810. So let's go through them one by one then. Now, what do we need to multiply that? Now, by the way, guys, when you have 3 of them, you can't use the little diagonal trick. You have to actually use your calculator. It's not going to work because there's 3 of them now. So you got to take the 810 and you got to divide. Take the the new denominator, divide by the old. So divide by the 9. So 810 divided by 9 is it 90? Yeah. So that means for that first one, you need to multiply top and bottom by 90. 5 times 90, what's that? 450. Good to there. The next one, divide, the new denominator divided by the old one, divide by the 30. What's that, 27? 27, top and bottom, 1 times 27 is 27. And then the third one, divide by the old denominator, 81, and that's 10. Top and bottom. And that's 20. Is that okay? See how I got those new denominators? Just divide the new denominator by the old. And then we can add all those up. So what do they have to be? Some big number, 47. Is it 497? Over 810. That's a little messy. We good? Questions I can answer? Everybody okay with that? With the box thing, finding the common denominator, and then divide by the old denominators. So in a minute, like I said, we're going to letters, and the point is, notice you multiply top and bottom by the same thing, don't you, to make common denominator. We're going to do that with letters in a minute. Okay, so number 8, here we go, got an LCM. 175 and 25. So, all right, so now we have numbers and letters, a mix, got both things. How do you find the LCM when you have numbers and letters? Well, first off, put the numbers in the L box thing. Put the numbers in the box, 175 and 25. Do the regular thing for them. So use your calculator, divide. What goes into both those? 5, I guess? 25 would be even quicker, huh? 5... 7, is it 35 times, I think? Yeah. And 5, then you can do another 5. Yeah, it would have been quicker just to do 25. There we go. Multiply these together now. 5 times 5 times 7 times 1. 7 quarters. Is it 175? So 175 is itself the number, part of the LCM. We got to do the letters still. So the LCM is the number part of the LCM is 175. Is that okay? Am I going too quick? You with me? 175. Everybody okay with the little box stuff? So now, what do we do about the letters? For the letters, you take the highest power on each letter. So I'm going to take the highest power on Z. What's the highest power I see on Z? Here's a 5, here's a 6, the highest one is 6. And then the highest power on X. Here's a 2, here's a 6, highest one is X. We're done. So we good there? So you just do the numbers like normal, put them in the L box, and divide out what you can, and multiply them together at the end. And then for the letters are actually easier than the numbers. You just take the highest power of each letter. Highest Z, highest X. No questions? So they're going to give us, they do give us x squared minus 49 and 7x plus 49. All right, well, the first thing that needs to be done here, first factor. See, these are not factored. They need to be. So how do you factor? Today's the factoring test, so this will be good practice. You guys are all practiced up, I hope, on factoring. How do you factor x squared minus 49? That's right. I'm glad to hear that in unison like that. All right. That's right. X plus 7, x minus 7, it's the FL or double, or whatever you want to call it. And then how do you factor 7x plus 49? Just take out the 7, huh? On that. Good. That's just a GCF, right? Okay, so I've got them both factored now. They're separate. They're separated by a comma, notice. So they're this thing and this thing are separate. Now, for the LCM, let me be real clear here. Out front numbers do the box, the L box thing. For letters, one of each type to the highest power. So here we go. So the LCM. So out front numbers. What are the out front numbers? Well, just that 7. He's the only out front number. So if there was a couple of out front numbers, like if there was a 7 here and like a 21 there, then I would put the 7 and the 21 in the box and do the 7, goes in 1 time, goes in 3 times, and times them together. You know, I do the whole thing, right? If I had a couple of out front numbers, then I would put both of them in the box and do the whole box thing. But I just have one out front number. All I have is the 7. And so all I'm going to do is put the 7 there. For that. Okay, now we got to do the letters, though. How do you do the letters? That's the numbers. How do you do the letters? So we did the out front numbers, now the letters. One of each type to the highest power. One of each type. One of each type. Now remember, plus and minuses glue things together, right? So this is an x plus 7 package, glued together, inseparable package. You can buy from Costco. The whole x plus 7 package, or not, right? It's a whole package. Then there's an x minus 7 package. That's different. So, and then there's another x plus 7 package. Okay, so what does it say? One of each. So what it is like you're going to go to the store, you're shopping at Costco, you're going to buy one of every different type of item, but you're going to buy the most expensive one, right? Imagine you go to the store to do that. I'm going to Costco today, and I'm going to buy one of everything. That would be a lot of shopping. One of everything in the store today, but I'm going to always buy the most expensive. So I look at the milk, I'm going to buy the most expensive kind of milk. When I look at the cheese, I'm going to buy the most expensive kind of, just one. But it's going to be the most, right? So that's what I'm saying. Highest of each. So I'm going to buy 1x plus 7. What? There's no powers on anything here, huh? So you just buy 1, you buy 1, and we're done. We do not take, because some people think, Mr. Shouldn't you do squared because there's 2x plus 7s? No, remember, you're only buying one of each type to the highest power. There's no powers on them. So that's it. Does that make sense? Now, well, let me just leave it at that, and that's the answer for that. There's more to see in other examples. So, for the letters, one of each type. For now, just one of each type. All right. So, we got 15, c to the 7th, a to the 5th, comma. The next one is 3c squared, a to the, what's that, 8? Yeah, 8. Comma, and 35, c to the 3rd, a to the 5th. Okay. So, the 3 out front numbers, the 15, the 3, and the 35, put them in a box, right? 15, the 3, and the 35. So put those in a box, do the box thing, find the number part of the LCM, and then for the letters, those are easier. Highest power on C, highest power on A. Done. that a try, so we can do those numbers. Okay, so what goes in here? Like 3, I guess. 3 goes in there 5 times 1 time. Doesn't go into 35. Just bring down the 35. And then you could do 5. Or you could have started with 5. The order doesn't matter. Do 5. 5 goes in there once, goes in there 7 times. Bring down the 1. Good to there? And then multiply those together. 3 times 5 times 1 times 1 times 7. What do you get? There it is. Thank you. 105. So the LCM, the number part of the LCM is 105. We good so far? And then for the letters are easier. You just remember what you do. Shop at Costco, you take one of each type. So I'm not going to take all 3 of these C's. I'm not going to take every brand of cheese. I'm just going to take the most expensive one. Just one of everything in my cart. The most expensive cheese. C to the 7th. Right? One of every one A. Which one? The most expensive one. A to the 8th. That makes sense. So we're not adding powers, are we? We're just grabbing the most expensive one. That's what we're doing. It's the highest power in C, highest power in A. Same thing will be true in a second with the parentheses and the powers on those. Same thing. One of each type, the highest power one. Good? LCM? Makes sense? Not a big wrinkle, but a little wrinkle. So, y squared minus 10y plus 5. Yeah, can you go ahead and factor both those? Go ahead and factor. You guys are all practiced up on factoring. Take out the 2, right? That's just LCM. That one. The other one's the 2 parenthesis thing, y's in the front. What multiplies to be 25 adds to be minus 10? Minus 5, minus 5. And what do we always do when we have 2 identical twins? Square it. And that's going to really be important in this chapter because we're looking at the power to make decisions, right? I'm saying take the highest power. So we got to see the power. Does that make sense? So definitely when you got twins, write it as squared. For sure. So when you got twins, definitely write it as squared. Okay, so we got them all factored. Now we're ready for the LCM thing. So remember the rule. You're shopping at Costco. You're going to buy one of every type of thing in the store, but only the most expensive type. You're not going to buy this cheese and that cheese. So in other words, well, first off, there's numbers. Out front number 2. He's the only out front number. Just bring him down. Right? If there was like a 10 over here, then I would put 2 and 10 in the box and do the box thing. If there's a couple of out front numbers, you put them in the box and you do the box thing. But if there's only one out front number, well, then he's it. That's the number part. Now, how about this letter package and this letter package? I'm not going to take them both. It's not going to be y minus 5 to the 3rd. Right? Remember, we're not buying everything in the store. We're buying one of each thing. One of every type of thing. So am I going to buy this one or that one? The squared, the higher power. That's why it's so important we show that power for the twins, because you're taking the highest power.
So if there was like a y minus 3 and a y minus 5, would you take both of them?
Exactly. You're thinking right on the money. All right, everybody hear her question? It's a good one. If this was y minus 3, then I would also need one of those. Yeah, because we're getting one of every type. Yeah. We got to have one of everything. We're going to the store. We got to buy one of everything. But no doubling up, right? I don't take the cheap cheese and the expensive cheese. I'm just buying the most expensive of every type of thing. So there we go. Is that good? Yeah, they're in and out. Yeah, they're all food. In and out burger, they are. They're all food. So this class is around lunchtime. I'm just always hungry. All right. So LCM. So x squared minus 81. And is that what I do? 9 minus x. All right. So Yeah, that 9 minus x, let me help with that. They're just trying to be tricky there. What should we do about that? Yeah, but don't worry about it for now. For now, we're going to do something in a minute. We don't got time for doing anything else right now. Let's just factor this guy. X minus 9, x plus 9. Good so far. That's an FL, double-double, whatever you want to call it. Good. And we'll just leave 9 minus x as 9 minus x. Okay. So as you look at that, what's the LCM going to be? That 9 minus x, it's basically the same as x minus 9. It's technically a small difference. But for now, we don't have to do anything. In a minute, we'll do something. But for now, it doesn't matter. Just say, hey, this and this, they're the same thing. They're a 9 and an x glued together. They are. The order matters a little. For something we'll do in a minute, it'll matter. But for now, if you're just talking LCM, who cares? It's basically the same thing. So just take one of them. You could take the x minus 9, or you could take the 9 minus x. It doesn't matter. And, of course, you need the plus, because that's different. So you definitely need the plus. That's different. Right? You need one of every type. And the plus type and the minus type are different. So you definitely need the plus. So you could answer this, or you could answer that. It's the same answer. Does that make sense? The x minus 9, the 9 minus x, they're the same thing. And you need an x plus 9. Either one's good. Is that okay? Because remember what you need. You're shopping, you take one of every type. You need one of the subtraction type, one of the adding type. You can use either brand of the subtraction. They're the same thing, basically, for now. All right, so this is going to be more factoring. So we've got 4t squared minus 17t minus 15 comma, and the one in the middle, 3t squared minus 16t plus 5 comma t squared minus 25. Okay, so, oh yeah, this is a big pain. This is a big factoring, three factoring questions, huh? So we don't got a lot of time to fool around, so I'm just going to do it quick. So FOIL, right? You guys okay with these? Remember the numbers in the front, you can do the whole FOIL thing when there's a number in the front? 2t, probably. I don't know. 5 and 3, is that going to work? 6 and 10, no. 30 and 2, no. Oh, okay, it's 4t, 1t. So you just got to fool around till you get it. Remember, these are a lot of guessing. It's going to be 4t and plain t. The 5's going to be here. The 3's going to be there. How do I know that? I'm just fooling around till I get it right. You know what I mean? Like if I was just to write these in and check the inner-outer stuff, right? The 2 inner would be 3t. The 2 outer would be 20t. See how they can make the middle? Minus 17t. If the 20 is negative and the 3 is plus, 3 plus, the other one minus. That's right now. So it's just, you just got to keep fooling around till you get that one. Now this one factor, going to be 3t, 1t. How do you make 5? It's going to be 5 here, 1 here. The 2 inner make 1t. The 2 outer make 15t. How do they make the middle term minus 16t? Both negative. Negative, negative. Finally, the one on the right, this one, is t plus 5, t minus 5, isn't it? So we have 3 separate. So a bunch of hard factoring. You guys could do it. It's just got to do it quick to keep it moving here. So now that we have them all factored, we're shopping. What are we going to do? Buy one of every type. Throwing in our card. There's no out front numbers here, huh? No out front numbers at all. It's just all letter packages. So I'll just throw one of those in the cart. Here's the LCM. Throw a 4t plus 3 in the cart. And throw a t minus 5 in the cart. Throw a 3t minus 1 in the cart. T minus 5, already got one of those. T plus 5, throw a t plus 5 in the cart. T minus 5, already got one of those. There it is. We're done. So that's the LCM. Just one of every type. One of every type is the LCM. It's common denominator is what it is. In a minute, we're going to use it for common denominator. Is that okay? Questions on that? Today's the factoring test. Are y'all guys okay with all that FOIL factoring stuff? Working all those out. Those are hard ones. That's going to be like about one of the hardest things on the test today is those kind of hard inner outer foil ones. All right. Okay. Y to the 7th plus 4y to the 5th, comma, the other one is y to the 3rd minus 4y squared plus 4y. Okay, so try that one. See if you can factor both those. Take out y to the 5th, y squared plus 4, GCF, like that, right? Take out, or I mean, yeah, GCF. Y to the 5th. Keep going. And how about these? Oh, can y squared plus 4 go again? Can't do it again. Does everybody know that it's not y plus 2, y plus 2? That's not right, right? Because if you foiled that out, it wouldn't be y squared plus 4. You'd have a, what is it, 4y in the middle. It's not right. So everybody okay with that? Remember, the plus FL can't do it. If that was a minus, if that was y squared minus 4, then yeah, it'd be 1 plus 1 minus, huh? So remember, the minus in the middle, you can do it. The plus in the middle, you cannot do it. Is everybody okay with that? You remember that? Mm-hmm. So it just stays that way. There's nothing more it can do. Right? It's an FL plus. FL plus, front last. Plus, can't do it. So it's okay. It just means it doesn't go any further. It's just stop right there. The other one, take out a y. Y squared minus 4y plus 4, and that'll go further, right? Is that that's minus 2, and those are twins, right? Yeah. So that's, whenever you have twins, you make it squared. So that one's completely done there. This one was only a one-stepper. We okay? We good with factoring on both those? Is that okay? All right, I always feel like I'm begging you for questions, but I'm glad to answer them. And probably other people might be thinking the same thing, so I know I can help a few of you at once. Is that okay? Feel free to speak up. Now, can you do the LCM from there? So you're shopping one of every type, right? One of every type, but the highest power one. So we look at that y to the 5th, and we look at that really y to the 1st, huh? And we're not going to get them both, right? We're only going to buy one of every brand of everything, so just going to take the y to the 5th, huh? And then we look at y squared plus 4, and there's nothing else like them. So we need one of those. And then we need this guy. And we're done. One of each type, the highest one. So I just took one of those y's. I didn't take the plain y, right? I just took the y to the 5th. I didn't take the y to the 1st. So whenever you have a repeating, matching, identical item, you just take the higher one, not the lower one, and not both. Good? Like you can do all these. I think we're close to the end of the LCM, laying the foundation so that we could now combine fractions. So here we go. We have 8y plus 3 over y minus 4 minus y minus 4 over y minus 4. Okay. We need to subtract those fractions. All right. So this is nice. They already have a common denominator. In a minute, they're not going to have a common denominator. We'll have to do a lot of hard work. But this one's nice. They've already got common denominators, right? So we could just go ahead and make it one big fraction. You know what I mean? We don't need two separate y minus 4s. They already match. So I can just, make it one big fraction with the same denominator, the common denominator. And I'll bring down the 8y plus 3. And then minus y minus 4. Is that good so far? Is that good so far?
You should just make the second one 1.
Do what's that? Oh, the 1. It is a 1. Yeah, you're right. I mean, good observation. This is a big fancy 1, but that wouldn't be helpful. It's true, but not helpful. So what I mean is, if I made that a 1, then like that, then how would I combine them? Because what they want me to do is make them into one fraction. So it is a 1, but if I wrote it that way, then I'd have more trouble putting them together. I'd like to keep it as it is, because that way they already have the same denominator, and I can combine them. Yeah, so everybody said it's a good observation. It is 1, but I don't want to do that because I want to combine them. Okay, so is that good to there? Is that good to there? You should be saying, no, Mr. Heron, that is wrong, because I've made a mistake. But so many people make the mistake, in fact, that you're not seeing it maybe. That's wrong. A small mistake, one sign is wrong. What sign is wrong? Yeah, that should be plus 4. Super easy to make that mistake. I just did it and snuck it past all of you. Right? Super. Really, I think if I made a top 10 list, it might be number 1 or number 2. Probably number 1. Of the one that gets people the most. So I say all that to say, let me give you a special thing so it does, because these problems are a pain enough. These next 13 problems we do are, which we're not going to get through them all, I don't think, but they're really tough. This is messy. It's going to be real messy. And you don't want something else like this getting you 2 on top of everything else. So here's what to do. Here's why this is wrong. First off, this minus sign is supposed to hit both these guys, not just the one in the front, and make that plus 4. So easy to forget about that. So what I'm going to suggest is I'm going to basically say, hey, just never subtract. Just never, ever subtract. What do I mean never subtract? Well, have you ever thought about it, that when you're subtracting 7 minus 3, I mean, I'm sure you have thought about it. It's the same as 7 add negative 3, right? It's the same answer either way, of course. So what I'm saying is, yeah, instead of subtracting, add the opposite. Just add the negative. What do I mean? Well, when they give you subtraction in the beginning, you think never subtract, is I'm going to add the negative. Now, how do you do the negative on the fraction? Well, remember, a negative in front of a fraction can go to the top only or the bottom only, but not both. Right? You with me? Like if I go negative 3/7 in the front, that's the same as the negative on the top only or the bottom only, but not both. If you put the negative on both, 2 negatives, that'd be positive. That's not right. Right? You with me? You don't put it top and bottom. Right? Everybody with me on that? A negative in the front, top only or bottom only. Either one of those is okay, but not on both. Okay, and so I could take that negative that's in the front, right? Instead of subtracting, I'm adding the opposite. And that negative, where's he going to go? Well, I could take him to the top only, and it had everybody in the top, both of them, which is what I'm going to do. Or you could take him to the bottom. I don't want to do that, though, because I've already got the bottoms matching, huh? I don't want to mess with the bottom. So I'm going to just go boom, boom. And then it becomes add negative y and plus 4. Good? So never subtract. Instead, add the opposite. And that minus sign, always let him distribute to the upper right. So let me write a note about that. So never subtract fractions. Never subtract fractions. Instead, distribute the negative to the upper right and add. We're adding the opposite, right? We're adding a negative. Same thing as subtraction, but that way you won't forget about the minus sign, which it causes so much trouble. So, all right. So we'll never subtract fractions again. We'll add opposite. So now just combine like terms. 8y minus 1y, what's that, 7y? 3 and 4 is 7, right? and y minus 4, and we're done. What did we do? We combined the two fractions into one. That's all we did. We took two separate fractions, put them together, one fraction, done. Simplification. Good? Combining two into one. Questions? All right, so I've got b squared over b minus c plus c squared over c minus b. Okay, so do you know what happens? Notice, the name of the game is common denominator. I've got to make those bottoms match. Look at them. They're almost the same, but they're reversed. A minute ago, for LCM, I said, it doesn't matter, mostly. And for then, it didn't. Here, they are basically the same, except they're opposite order, which means if you just multiply one of them by -1, it will match the other one. All you need to do to fix this, and we do need to fix it, right? Because you got to have the bottoms the same. Everybody with me on that? You getting the big idea, right? You cannot add fractions with different denominators, right? If you tried to, that is not 9/14, for example. That's not true, right? If the denominators are different, you may not add them. It's just not the truth. It's just make-believe right here. Let me show you how untrue it is, right? What if we thought it was true that you could add a half and a third, and you could just add the cross? Why did math make the rules that way? Why didn't they just say add the top, 1 and 1 is 2, add the bottom, who cares if they're different? It's all good. Just do adding that way. Why didn't they do that? It'd be so much easier, right? Carrie, it'd be way better. Yeah. Well, because what's the answer always in math? Why they do what they do? To make life hard for math students. No, not that answer. Because they said no. They just said no, like a parent. They just said no, no explanation. It's just a no. It's because it's not true. What do I mean not true? Well, think about real life. Think about a pie. If I have half a pie, right, half a pie, and I take a third of a pie, so it's a little bit less than half, third. You add them up and you get 2/5 of a pie? That's less than half. Where'd the pie go? Right? I took a whole half, added some to it, got less. It's just not true. It's just not true. Right? So, all right. So I want to make sure I'm clear, because the rest of this section is all about making the denominators match. You can't add them unless the bottoms are identical, right? That's the big deal. That's why we're going to do all the hard work we're going to do, is to make these bottoms the same. All right. So I got to make these two guys the same. They're almost the same. I can fix it by multiplying by -1. Let me show you. But you got to do top and bottom, because otherwise you change the fraction. You with me? Whenever we do something to a fraction, we do top and bottom. So we don't really change it. We just make it look different, right? What happens when you do the bottom? Boom, boom, minus c plus b, which is the same as b minus c, isn't it? See how we made it match the other one? See, it's b minus c now? You guys with me? Remember, you can reorder things as long as the same sign is in front. It hasn't changed. Right? Negative is in front of C, negative is in front of C. Positive in front of B, nothing in front of B, it's positive. This is the same as that. You're with me? I'm giving you too many facts too fast. So let me rewrite that part a little neater. Same as B. Do you see that we effectively turned it around, didn't we? By multiplying this -1 and changing the sign on the C, and changing the sign on the B, we effectively made it match the other one, didn't we? We made the denominators common denominator. We achieved common denominator, right? So, all right, so what do we have now? B, the left one has just been sitting there watching. We didn't do anything with the left one. The one on the right, negative on the top, I forgot to do the top. Let's do the top also. Minus c squared. The bottom has now turned around because I multiplied the bottom by -1, which effectively flipped it. And now we can add them, because now the bottoms match, which is the only thing that's true. You have to have the bottoms match. What's on the top? B squared plus minus c squared, but who cares? You know it's just minus c squared. Right. Good to there so far? I combined them, so the two fractions have become one fraction. The two have become one. Now Normally I'm done there. Every now and then you can do one more step. Very rarely. This one I can do one more thing on the top, huh? I can factor that top. B plus C, B minus C. And it will actually cancel. And so the final answer is just B plus C, isn't it? So that's rare that at the very end, sometimes you can factor the top. Only about 1 out of 10 problems will do that in this section. Is that okay? So what's the name of the game when you add fractions? Make the bottoms match. Make the bottoms match. That's what the whole rest of this section is about. Make the bottoms match. What you have to do, because that's all that's true. Denominators must be common to add fractions. Otherwise, we're doing make-believe stuff. It's not true, right? We're losing pi and stuff like that. All right, good? Everybody good to there? Does that make sense? So what did I do? When you see things turned around, I call it, what do I call it? Turnaround rule? I mean, call it whatever you want. Turnaround rule. So that's basically when denominator opposite, subtracted opposite order, reverse order, multiply -1, top and bottom. Right? That's what I did. Multiply top, bottom by -1. And that, what did that do to that denominator? It turned it around. It turned it around, didn't it? Because it changed the signs, which is what it is to be turned around. All right, 6 over z minus 5 over minus z. Got a couple minus signs there. Just put them together, right? Because remember, a minus in the bottom of a fraction is the same as the front. Remember like a minute ago I just said, if you have minus in the front, you can put it on the top, or you can put it on the bottom, so you can go from the bottom back to the front, huh? So just take that minus that's in the bottom and put it back in the front, and then what do two minuses do? Positive. And now they have common denominator. Done. Everybody good with that? So you don't have to do it so slowly as I did it. You could just look right away and go, look, 2 minuses plus. That's fine if you want to just jump right to it, you know. Because that's what will happen. Those 2 minuses will just make plus. And then the denominators are common, which is the name of the game. As long as the bottoms match, we can finish it. So 8y minus 72, y squared minus 81. Okay, what do you see? Oh, you know what I would do actually first, even before I think about that? Never subtract. I would do that first. Yeah, you don't have to, but I think it'll be easier for you. Never subtract. Instead, move the subtraction, or distribute. Yeah, distribute the subtraction to the upper right. Remember that? So I would do that first. Never subtract. Instead, add and put the minus there and there. Right? That minus sign went boom, boom. So I just always let subtractions distribute to the upper right. Boom, boom. Hits both the things in the upper right. See how it hit the 9, made it -9, hit the negative y, made it positive y. Is that good? Kind of getting scribbly there. And now it's adding in the middle, right? Now I'm adding the opposite. Instead of subtraction, add the opposite, just so that you won't mess up on the signs later. It's so easy to mess up. It's like the most common mistake. Good to there so far? Now, let you take it from there. Now deal with the denominator. So first, never subtract. Get rid of subtraction. Never mess with subtraction. Now, do something about the denominator. They're turned around, right? So do the turnaround rule. turnaround rule here. So, which means what? Which means I'm going to multiply top and bottom by -1. And it'll go boom, boom, making that minus 81 and plus y squared, which is the same as y squared minus 81. We turned it around. And what happens on the top? Boom, boom. So that'll be plus 9 minus y. Now, I don't care about, you think, well, should I turn around the top? I don't care about the top. Remember what my goal is? Common what? Common denominator. All of my thinking, my focus, my intentionality is with the denominator. I don't care what's happening on the top. Whatever, who cares? Don't reorder it. Don't mess with it. Just let it do what it's going to do. Who cares about the top? But the bottom, I care a lot about, because it's all about the bottom, isn't it? It's all about common denominator. So does everybody see what happened there? So now I have y squared minus 81, 81 minus 72, plus, and now I have turned around the other denominator by multiplying top and bottom by -1. What happens on the top? 9 plus, or minus, 9 minus y. Good to there? Everybody okay? So what did I do? First step, never subtract. Let that subtraction distribute to the upper right. Change both the signs. Then, to turn this guy around to make the two denominators the same, multiply top and bottom by -1, turns around the bottom. On the top makes it plus 9 minus y.
Does it turn it around?
You can turn it around if you want to. You're saying, why doesn't it turn it around?
Yeah.
Yeah. So if you want to, yeah. Let me say this. We only turn around denominators. Like, could you turn around? Yeah, maybe. I could give you a whole thing on that, but who cares? It's only the denominator. Really good question. Everybody's tracking with me on that? Only turn around the denominator. Right? Why? Because we want common denominator. Right? Our focus is denominator. All right. Now we can put them together, can't we? Now they match. Question? You good? All right. 8y minus 1y is 7y. And minus 72 plus 9. What's that? Calculator? Minus 72.
I'm confused a little bit.
Minus, is it minus 63?
Negative.
What's that? Car?
Why isn't the 9 negative?
Where's it? Yeah, it was negative here. And this minus 1 went boom and boom. Made it plus 9. Tracking with me? See how it was minus 9 right here? So at first, there was two changes that happened. First one was the subtraction in the middle. There's two rules that went on. You got to track both of them. Never subtract. So that minus in the middle hit the 9 and made it a minus 9 at first. And hit the negative y at the back and made it a plus y at first. And then secondarily, I brought in another -1. Why the other one? Because I had to turn around the bottom. And that second minus changed the 9 back to plus and the y back to minus.
Okay.
So in the end, it ended up the way it was from the beginning, huh? So we changed it twice. We good to there? Can we do more at that point? Yeah, this is one of those rare ones where the top does factor. Take out a 7. Bottom is y plus 9, y minus 9, so these cancel, huh? So it's just 7 over y plus 9. There we go. Is that okay with all those little sign things? Those signs cause a lot of headaches. So is that making sense? You okay with tracking those? So never subtract. Subtractions, first thing, before anything else, never subtract. Subtraction goes to the upper right, changes all the signs in the upper right, distributes to the upper right. And then, different order on the denominators, multiply top and bottom by -1. And that changes the signs and turns it around. Okay, so notice those two different actions. The subtraction minus only goes to the top, right? But the turnaround is top and bottom. Are you all seeing that? So here's something I can say to help. Whenever you bring something new that wasn't already there, that's what I mean by new, right? It's new. Got a new sofa, wasn't in my house before. Got a new minus sign, wasn't in the problem before. So whenever you bring something new in, you got to bring it in with balance. You can't just do the top. You got to do the top and the bottom, because otherwise you change the problem. Now, this minus, this subtraction, was he new or was he already there from the beginning?
Already there.
He was already there. I didn't put that minus. That was part of the problem they gave to me, right? Whereas this minus and this minus, I brought in new. So everybody see the difference between those kinds of actions? Right? This subtraction was part of the original question. That's why it only goes to the top. It was already there. I didn't bring it in new. It's already there, waiting to do something. And what does a minus in front do? Top only. Whereas these minuses, that was something new I brought in to do a purpose I had. So when you bring something new in, you must bring it in with balance. Otherwise, you change the problem with your new thing. Right? So that's why that does top and bottom. Everybody seeing that? That making sense? Yeah, let's do this question, and I'll write out some. I'm going to write out some formal steps now, because this one really kind of has everything in it. So I want to do the whole thing. So 16vx over v squared minus 16x squared plus v minus 4x over v plus 4x. Okay. So what's the deal? Here's the rule for adding, subtracting fractions. I'm going to do a 0 step, because I'm going to say step 0 because you don't always have to do it. I'll say never subtract, as I said a couple times. Never subtract, distribute, subtraction, upper right. Never subtract. You know that. So I'll go on. So I call it step 0 because it's not always necessary, right? A lot of times, like this one, we just have plus in the middle, so we don't have to worry about that. Most of the time you don't. So I'll just call it step 0. You don't always have to do it. Just if you have subtraction, do it. Otherwise, skip it. All right, step 1. Factor denoms. Step 2. Multiply top and bottom by the missing part. I'll explain. So top and bottom. Step 3, multiply out the top. Multiply out the top. Step 4, try to factor the top. There we go. There's our, well, and cancel. There's our four steps. And cancel, yeah. So there it is. So there's the steps that we're going to go through for adding and subtracting fractions. So not all those steps are always necessary. We've been doing kind of parts of those steps. This one will have most of those in it. So step 0 is the never subtract thing. Step 1 is factor denoms, multiply top and bottom. Step 3 is multiply out the top and then factor the top. Notice something to help. Notice the first 2 steps are about denom, well, but they're both about denominator. And steps 3 and 4 are both about the top. Notice that. So step 1 and 2 both are all about the denominator. So we do the denominator stuff first, common denominator, achieving common denominator. And steps 3 and 4 are then, okay, now that you got the bottoms good, finish up the top. That's basically the way we attack fractions. So steps 1 and 2, get the denominator issues in line. Steps 3 and 4, okay, now turn your attention to the stuff on the top. So here we go. So step 0, no, we don't have subtraction, so skip it. Step 1, factor denoms. That'd be this guy right here, huh? He needs to be factored, doesn't he? So let's factor him. What are we going to have? 16vx over, what is that? V minus 4x. V plus 4x. Plus, and then the other one. No change. The other one didn't need to be factored. Okay, we okay? That's step 1. I factored the left denominator, the lower left corner, needed to be factored. I factored it. It's just an FL, right? Everybody good so far? Just v minus 4x, v plus 4x for v squared minus 16x squared. This one doesn't need anything. Okay, good. Now step 2. Multiply top and the bottom by what's missing. Okay, what am I talking about? So what I mean is we're going to come in here and I'm going to put parenthesis top and bottom of this guy and parenthesis top and bottom of that guy. Get this out of the way here. And I'm going to multiply them by what is missing. What the other guy has, like comparing to your neighbors, right? What do the Joneses have that I don't have? My neighbor's got a really cool Mustang thing. GT, it's a Mustang GT. He has the hood up a lot. He kind of rumbles down the street. He's about my age, you know, and I've got the old family van that's like 15 years old. My sweet daughter learned to drive on it, and in her first year, I gave it to her because she was going down to Reedley to take animal science classes, and she had a few accidents in her learning process. She's doing great now. She's had an accident for a year now. But her first, so it's got several dents. I mean, and I didn't want to fix it because it's old. So I just said, whatever, just leave it. So anyway, that's what I drive. And my neighbor's got the souped up, beautiful Mustang. So sometimes I compare to my neighbors. And I go, what's the difference here? And then I count the children, and I understand. He's got 1, I've got 5. So that's where my money goes, and not to the nice car. All right, anyway. So comparing to your neighbors, really not a good practice, but it'll work for the fractions. So we look, this guy compared to those guys, what do these guys have that he doesn't have? V minus 4x. So give it to him top and bottom. I'm bringing that in new, right? That's new. Anything you bring in new, you must bring in with balance, right? Top and bottom. Top and bottom. Right? Anything new, bring it in with balance. Now, what about this guy? Does this guy need anything that guy has? No, he's got it all. He's a neighbor that's got it all, right? He doesn't need anything. So I'm not going to give him anything. And notice right now, the two denominators are now same, aren't they? Made them the same. Yeah.
So you can't cross cancel because it's not multiplication.
Good job. You're totally right in the money. I'm glad you brought that up. If this is times, we would totally cross cancel. It's exactly right. Yeah, we would start canceling stuff if it was times. That's exactly right. Plus and minuses we can't. And you know what? Just let me expand on that. I'm really glad you pointed that out. Let me say even a more general thing that'll help in a lot of situations. Generally, pluses and minuses are all the hard rules, not the nice ones. So when you look at like cross canceling, that's a nice, easy rule, right? You should just think, probably can't do that if I'm adding, subtracting. You'll be right. Pretty much any nice rule, if you're adding, subtracting, never's allowed. It's adding, subtracting that make all the hard things in algebra. If that was times, we'd totally just cross cancel. This would be a simple question, but it's adding, so it's not. Good observation. We good to there so far. I'm doing step 2, multiply top and bottom by gave this guy what he's missing so that he now matches the other one. Like if I went down and bought myself a Mustang GT, I don't think my wife would be too impressed. And we'd have... You know, I remember one time I used to say, one more quick, we sold our house, it was years ago, like 12 years ago. We sold our house kind of near the top of the market, and we waited about 6 months because we're moving, doing some different things, before we bought a new house. So I had like over $100,000 sitting in the bank from the sale. And so I'd see like the advertisements for like the Lamborghinis and stuff, and I would think, you know, I could buy that car. I think I had like 150 in the bank. I can actually just buy but me and the kids would need to live in the car. You know, I'd have no more house, but I could buy that car. My wife always thought it was funny when I'd say that. I'm going to buy that car, honey. Yeah, you sure go ahead. You buy that car. Anyway, so I'm getting lost. Yeah, see what happens, yeah. All right, so multiply top and bottom. Now they match, right? We gave them what the other one had. Now they match. Okay, step 3. Now we're done with the bottoms at this point. Steps 1 and 2 are over. We're done with the denominators. Done. They match. As soon as you make them match, forget about them. Like I'll just put down here, you can just write LCM if you want. I mean, whatever. We're not going to touch the bottom ever again. We're done with the bottom. So leave it be. Don't multiply it out. Don't FOIL it. Don't do anything with it. Just leave it. We're done. As soon as you make the bottoms match, you're done with the bottoms. Hands off the bottoms. Now all of your attention turns to the top. What are you going to You're going to multiply out the tops. Gather them up, see if you can factor them. You usually can't. which is great. Usually you're just done. So bring down the 16Vx. And then this guy, FOIL it out, right? So that'd be what? V squared minus 4Vx minus 4Vx plus 16x squared. Is that good? I just FOILed out this denominator, numerator, and just brought down the 16Vx. Gather like terms, what do we got? I don't know, it just looks like a big mess. Bring it over here. It looks like the 16Vx and the minus 4 and the minus 4Vx, that's 16Vx minus 8Vx. That's 8Vx, huh? Plus V squared plus 16x squared over V minus 4x V plus 4x. Oh, we should reorder those, huh? Yeah, let me put, this one's going to do the extra step. I was hoping it wouldn't. They usually don't. Okay, let me reorder this one. This is what, 8Vx? Yeah, this one's going to do one more step. Usually you're done at this point. Everybody good to there so far? I just combined like terms on the top. Right? V squared, I'm putting them in order. V squared, and then 16Vx minus 4 is 12, minus 4 is 8, Vx plus 16 squared. Now, last step, which usually you don't have to mess with, but this is an especially hard one. That top will factor. See that top? That's the last thing you try. Usually you don't have to mess with it. That top will indeed factor. It's V plus 4x, V plus 4x. Do you guys see that on the top? V squared, 16x squared at the back. They add to be 8, right? 4 and 4 add to be 8. So what that means is these guys cancel. Final answer, V plus 4x over V minus 4x. That's my final answer. I cannot cancel any more here. Nothing more will cancel because the pluses and minuses glue them together. Remember that? So that's it. That was a little painful at the end there. So that was tricky. All right, we didn't quite finish. I didn't think we got 8 left to go. So 5.2 is not due yet. 5.2, it will be due next Tuesday. No, next Monday. Next Monday. 5.2. All right, we need to take our examination.